Newton's Laws in Motion by Monica Wicks and Hannah Wong. Newton's first law: objects will stay at rest or in motion until there is an unbalanced force acting on it. So an object at rest or motion will not change until an unbalanced force pushes or pulls it. This law is also called the law of inertia, which is how much an object resists motion changes. If two equal and opposite forces are pushing on an object, then the net force is zero and the object stays still or moves at a constant speed, as shown in the image.
Newton's second law of motion. This law explains how acceleration, mass, and force are all related to each other. Force is equal to mass divided by acceleration, and the other formulas are in the triangle. Mass, force, and acceleration all affect and are proportional to each other. The triangle below can be used to calculate each of them. For example, if an object has a net force of 20 newtons and a mass of 5 kilograms, the acceleration will be 4 meters per second squared. Net force is the total amount of force on an object.
Newton's third law of motion. When an object exerts a force on another object, that object exerts an equal force in the opposite direction. The object that exerts a force on another object is called the action force, and the object it exerts force on is the reaction force. The reaction force exerts an equal force back onto the first object. In other words, forces always come in pairs. An example of this is when someone pushes off the ground on a skateboard. They're applying the action force on the ground, and the ground is applying a force back, causing it to move.
So now we can put it all together. This is an example of how all three laws work together to get a ball to move. So when the ball is at rest on the table, it's going to stay how it is at rest because of Newton's first law. So until an unbalanced force acts on it, it's going to stay on the table. When a person's hand pushes the ball pushes the person back because of Newton's third law. The person doesn't move because the force applied isn't strong enough. Mass, force, and acceleration are all related because of Newton's second law. For example, if the mass of the ball is doubled, the acceleration will be half as much when it's pushed. If there is double the force, acceleration will be doubled as well. And these are our sources that we used.